Hello and welcome to our second edition of our B5, the living body topic. Now today we're going to be looking at skeletons and we're going to be looking at the joint part of the skeleton. Okay, so here are our objectives for this lesson. By the end of this lesson on skeletons and looking at joints, you should know and understand the different types of joints that occur in the human bodies and how joints function to allow bones to move. A joint is where two bones meet each other. They are connected to each other via a ligament. Now, in order for the bones to move, they are attached to the muscle, and it's a muscle that uses a tendon to attach itself to the bone. Now, there are two types of joint. There is a fixed joint. Now this is where tiny pieces or plates of bone are fused together, such as in the skull. And then there is a synovial joint, which is where most of the joints happen. And for this you can get two types. You can have a hinge joint and a ball and socket joint. A synovial joint is where two bones meet. Now what happens when the two bones come together is they're not fixed together and touching. There is a slight gap between the two joints. So let's have a look at one. Now we can see on here we've got bone 1 here and bone 2. We can see that we've got the calcium and phosphate salts that have replaced the cartilage, but we've still got cartilage at either end. We've also got the hollow part where the bone marrow and the other blood vessels are. Now joining the two bones together we have ligaments here and on this side here. Now the cartilage on the end is there to reduce the amount of friction within the bones. The bones can be really quite painful if they rub together. Now we also have the synovial fluid that cushions the movement between the bones. Now the synovial membrane is able to secrete and protect and hold in that synovial fluid. Now, just to recap, here is a quick little table that shows what the 4 points do. So you've got the synovial membrane that secretes the synovial fluid that lubricates and cushions the bones during movement. The smooth cartilage prevents friction between the bones, and then you've got the ligaments that join the two bones together. Okay, so we're going to look at how the arms actually move. Now, on the diagram here, we've got the arm. Now we've actually got the two types of synovial joint. At the elbow here, we've got the hinge joint, and then at the top here, we've got the shoulder where the ball and socket joint is. Now, I'll just go through the anatomy of this. Now, here we've got the bicep muscle, which is here as well, and then here we've got the tricep muscle here. Now what I'd like you to do is pause the video in a moment, and I'd like you to hold your arm out straight, and I'd like you to do what the diagram here is doing. So move your forearm up and down like a bicep curl, or when you're lifting your shopping bags. Okay. Okay, so welcome back. Hopefully when you've done that, you've seen that when you hold your bicep at the top, when you pull your arm up towards your shoulder, you get the bicep condensing or contracting even, and making it feel nice and big. And then when you lay your arm out straight, it goes really long and stretched. And then when you hold your tricep, when it's up tight, when you've pulled your arm up to your shoulder, it's long and stretched, and then when you straighten it, it's contracted. Now this is what we call an antagonistic muscle. So when one contracts, the other relaxes. So contract, relaxes, contract, here, relaxed. Now this is because we have a fulcrum, which you may have come across in physics, where the elbow is able to move. Now here we've got one particular bone. This is called the humerus, itself not really very funny. And then we've got two bones here. We've got a thinner one called the radius, and then we've got the slightly bigger one called the ulna. Now what happens at this fulcrum at the elbow is that the radius acts as a lever to the hand. It can actually travel a much bigger distance than the muscles can. Now this is necessary because the muscle fibers can only contract a small distance, so they need to be able to move more so that you can use your hand. Now this is what we call a distance multiplier. Now replacement joints are exactly what it says on the tin. It means that you can take a joint that perhaps has broken, perhaps a bone has worn away, the socket has become damaged, the bone is broken, and you can replace it with something new. Now there are some advantages and some disadvantages to this, but let's have a look at what we're actually talking about. Now here we've got a replacement hip, and you can see the ball and socket. There's the socket and there's the ball, and then you've got this pin going into the bone that allows the joint to work again. Now advantages to this is you can have these tailor-made to suit your particular body. It's not like you go into Tesco's and you just pick up a joint, take it to the doctors and they'll fit it for you. They can actually design it and make it specific for your body. Now because there's no living tissue here, it also means that the immune system won't reject it from the body. Now obviously if you've got a worn out joint, that's why you'd want a new one, or you can perhaps have a repaired one if you've damaged it. That's what a lot of sportsmen do when they retired. It also means that old people can get their mobility back. Now we've got another one here. This is an elbow. Now one of the disadvantages for this is in order to put this in, you need to be cut up by the doctors, and that requires a lot of major surgery. Now once you've had this in, the joint will be fine, but it won't replace or repair any of the diseased or weakened bones that are in the body. Okay, so we've looked at joints with the skeleton today, and we've looked at the two different types, the fixed and the synovial joints. We've looked at the hinge joints and the ball and sockets and how they actually work. We've also looked at how the antagonistic muscles work to move your arm. The same will be applied for legs as well. We've also looked at what happens if your joints start to give in, which I hope not, but might happen to your grandparents when they get old. I know it's happened to my wife's grandmother. So yeah, that's what we've looked at today. I hope you've enjoyed it, and I'll see you next time. Bye bye.